Hello, welcome to Algorithmz. My name is Saurabh, and today we are going to discuss about security design principles for cloud and on-premises environment. As we know, most of the companies are moving to cloud, and their enterprise architects are busy designing security design principles for on-premises, IaaS, PaaS, and SaaS. So this presentation is going to help them with a broad range of design principles and what are the three key strategies or key strategic pillar they have to look at before even getting at the design principles. And if any organization or any business vertical, if they look at these 13 design principles, I think that's a good, not just a start, but it is going to give them a very good coverage from the design principles point of view. They can utilize whatever they need, means they can curtail it, tune it according to their needs. Let's look at three strategic pillars. The reason I chose three because it is based on the shared responsibility model. Since your physical host in your cloud, physical network, and physical data center is managed by a cloud provider, so you have to ensure that cloud provider is meeting the security best practices and regulatory compliance according to your requirements. Uh, Establishing a modern perimeter, as I said, means it is not just cloud plus uh, on-premise environment. We are talking about infrastructure as a service, platform as a service, and software as a service. Since you must be having different applications with different SaaS applications. Similarly, you might be having PaaS environment running IaaS as well. So it is a very common mix, all these four. So you have to design security principles which covers both, and you have to have a strategy or strategic pillars which cover all the three areas. So the reason behind establishing a modern perimeter, as I explained, these four different areas, plus you have to make sure how your information and data is secured, devices, accounts, and identities. From modernizing your infrastructure security perspective, you need to look at identity and directory infrastructure, your applications, network controls, operating system. Plus, at the same time, you must be having some legacy applications. So in past, getting an updated inventory of security patches is a tough task, or was a tough task. So whether, because discoverability was tough for different servers, and you don't know which servers are out of date, which are not. I'm talking about dev, staging, prod, all of them, because that list is not updated on the daily or a regularly basis, like weekly basis, most of the places I'm talking about. So if you deploy tools, rapid discovery tools, like Azure Security Center or Azure or AWS Security Hub, what they do is they quickly and accurately measure the patch state of all the servers and and remediate them based upon your requirements, based upon your schedule. So it is more of a maintenance schedule that you have to define in these tools. But from the discoverability perspective, you need to have a strategy where you are doing this in an automation manner. You are no more dependent on certain group of people who are going to maintain this data manually, about the inventory of servers and applications, security patches, Windows operating system patches, application patches, so on and so forth. Let's look at the different design principles. So number one design principle is align security priorities to your mission. So you need to look at your business goals, how the systems and data is classified, and then security resources should be first focused on assets and people with intrinsic business value, and those with administrative privileges over business critical assets. Building a comprehensive strategy, a security strategy should consider investment in process and security controls across all your system components. The strategy should also consider the full life cycle of your system. Design for attackers means most of the time when you talk to IT and application teams, you get their perspective of security, but at the end of the day, you have to reduce the potential attack surface from the attackers, and you have to look at the systems and design systems from the attacker's perspective. Leverage native controls. You can use cloud native controls uh, rather than external controls from third parties. The reason, there are many reasons, I would say. First of all, one cloud provider, they are maintaining their software, plus they are maintaining coming up with the different versions, plus integration is easy, so it eliminates or reduces effort required to integrate external security toolings and update those integrations over time, I would say. Use identity as a primary access control. I explained and emphasized on identity several times. Accountability means if you have security team, if you have application team, make them accountable for the assets, and you should also ensure that entities have been granted the least privileged access required to manage the environment, and the ownership of assets have to be clear. So does the security responsibilities. For instance, the dev team is responsible for DevOps kind of operation, because most of the time it's an application team which is managing the DevOps, complete DevOps. So how security is integrated in your DevOps environment, how they are maintaining it, is there any dashboard that they are sharing with the security team on a regular basis. So those kind of things are important. Automation, for instance, infrastructure as a code, so you are minimizing the configuration issues or configuration error. If you remember my previous presentations, I called out in one of the slides where how application deficiencies and configuration is one of the major areas uh, where attackers focus on, and I explained about application dependencies like dependable packages as well, how they make your application vulnerable for attacks. Resilience is also very important. You need to look at from the resilience point of view, I would say the balance of investment is very important. So look at your core functions, and also look at the full NIST cybersecurity framework lifecycle. And you have to ensure that attackers who successfully evade preventive controls, you cannot design 100% secure system, there is no way, because security is a concept, it's not the reality. So you can, it's a preventive measure, so you can prevent. So just in case if an attacker evade preventive controls, you have to make sure that you are able to detect them at the detection stage and respond to it from the recovery perspective. Ongoing maintenance is important because once you deploy security controls and assurances to ensure that they don't decay over time with the changes to environment or because of ignorant behavior due to some reasons. Ongoing vigilance, defense in depth, least privilege, all these six elements are part of design for resilience. Baseline and benchmark, if you are implementing security or if you are uh, hardening or strengthening your security perimeter, your organization perimeter, you have to have a baseline and benchmark. First of all, you have to have the industry baseline and industry benchmark. Then you have to have look at the region you are in and figure out are there any security controls or mitigation strategies, have you implemented it. For instance, in Australia, Essential 8 is a mitigation framework that organizations use, that is just a baseline framework. So that is a good starting point. If you don't have anything to compare with, you can take that as a baseline and then start to benchmark whether you are at Essential 8 level 1, 2 or 3. And then there are other frameworks as well like NIST and depending upon your organization, your business vertical, there are different compliance from the different institutions. So you have to look at different aspects and see what tools are using, and how are you baselining the system, how are you benchmarking the system, and how often do you do that. Is it done every month, every quarter, every year? So somewhere there has to be I would say a checkpoint in order to make sure that somebody is reviewing it, it is getting approved. uh, Driving continuous improvements. Assume zero trust. I explained assume zero trust several times in my past presentation, so I'm not going to spend time on this one. Educate and incentivize security. That's a very, very important point, because people who are designing and operating the cloud workloads are part of a whole system. Okay, so it is critical to ensure that these people are trained, informed, uh, to support the security assurance goals of the system of any specific business unit that they belong to, or if they belong to the or if they are managing overall security of the organization. And this is particularly important for people with accounts granted broad administrative privileges, right? So you have to make sure they are educated, they are getting training time to time, they are pretty much aware about different frameworks like Mitre attack, essential 8. If you are in finance industry, they have to be aware about finance regulatory compliance and how they are complying with those compliance. Again, it goes back to the baseline and benchmark, and how they are progressing. If they are not at I won't say if you are not at the in the top tier, how you are planning to get there is very important. I guess this is it from my side. Thank you very much for watching. Have a great day.